up, down, it's complicated. So I would also like to thank the local organizers, specifically for the invitation to give this summary talk. It's been kind of exhausting, but also exhilarating, exciting, and I actually have enjoyed it in a kind of masochistic way. I mean, it's really been wonderful. And above and beyond that, I would like to give a personal thanks to them for all the wonderful introductions to Korea, to temple tours, recommendations for restaurants, and just incredible hospitality. I'd like to apologize to the speakers at the Gong Show. I'm not going to review those talks, and perhaps I should apologize to Ed because I'm also not going to review his talk, but that would seem a little silly since you just heard it, and in any event, I wouldn't have had time to prepare anything. And I would also like to thank Igor Klebanov, David Morrison, Nadi Seiberg, Jan Manschat, Michael Douglas, Shamak Kachu, and Sergei Gukov for suggestions, helpful advice, and what might be called spiritual guidance during the preparation of this talk. So the talks here I thought were of very high quality. They were extremely interesting, and I thought they were presented with a clarity that went above and beyond many previous meetings, or certainly many meetings I've been at. So I thank them for making my job easier, and I think more profound thanks are going to be required, particularly to the local organizers, but David will be providing that after this talk. Now, I've tried to give equal attention to all the talks and all the speakers, but human nature being what it is, I know that I have not always done the job that I might have done. And I would just like to offer the following as an explanation. Those of you in the older generation might recognize this cartoon. Okay, Ginger, I've had it. Stay out of the garbage. Ginger, understand, Ginger? Stay out of the garbage or else. And what the dog hears is blah, blah, Ginger, blah, 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 Ginger, blah, 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 blah. This is what we say to summary speakers, representations of the BPS-ology of Harvey Moore, functor from Cosmology. And so if it seems that I may have paid some more attention to some talks rather than others, this is probably the explanation. So let me make a few general observations. String theory is in many ways now a very mature field. We have established results, although we don't have extensive experimental tests and confirmation. In some sense, we still have a very firm body of knowledge, and new results have to fit into that in a way that's typical of a more advanced field. Next year will mark the 30th anniversary of the Green-Schwarz paper on anomaly cancellation. And on a personal level, I find that coming face to face with this, somebody I think mentioned a paper that I wrote 30 years ago, there's a certain cognitive dissonance, and I think this is something that the older generation understands and the younger generation doesn't. And that got me thinking about what else there is that splits the two generations, a younger and an older generation. And I decided just somewhat arbitrarily to take the 30-year span of time between Green-Schwarz and now and divide it into two 15-year periods and declare anybody who got their PhD in 1999 or before to be the older generation and anyone after that to be the younger generation. So let me ask how many are of the younger generation? You got your PhD in 1999 or after. And how many are of the older generation? All right, so it's roughly a 50-50 split. So I, in conversations with various people, tried to think if there were other subjects like this. So here's a quiz for the younger generation first. You have 3 questions. I want to know how many of them you could answer. What is the value of C for the tricritical icing model, and why is it an interesting model? What did Daschen, Haslacher, and Neveu do? And what is HarvMac? So if you can answer all 3 of those and you're of the younger generation, raise your hand, you have to be honest. Oh, good. 2, 1. That's a pretty good distinguishing line. And now for the older generation, what is a motive? What does categorification mean? And could you actually construct this figure in LaTeX without the use of someone from the younger generation? So now those of the older generation, how many could answer all 3? Greg, you don't count. How many could do 2? 1? All right, those are pretty good distinguishing questions. So continuing on with some general observations, the study of supersymmetric gauge theory continues on in a very vibrant way. I would say even more than vibrant, as we heard in some of the last talks. It's really spectacular, the advances that have been made in understanding dynamics and also some of the mathematical understanding that's emerged from that. But I also detect a gradual shift, and it's very gradual because it's a difficult subject, towards trying to understand the dynamics of M-branes. There were many talks on Chern-Simons theory and on the 2-0 theory, both of a mathematical nature and trying to unravel this very deep puzzle of what the 2-0 theory actually is and how we study it. And we also heard about many new, several new exciting directions in mathematics related to BPS states, such as wall crossing, applications of the 2-0 theory, and M24 moonshine. So this is an era with a great diversity of ideas and applications, but there are many common techniques, and most of those techniques grew out of string theory. Perhaps not all, but even in studies of supersymmetric gauge theory, string theory is often lurking in the background. Much of our understanding of supersymmetry grew out of string theory, ADS-CFT, studying the dynamics of gauge theory through the dynamics of branes. All of this ties closely in with string theory. And we've also seen a maturity in the applications of gravity dualities. I think it's clear that these are not some panacea, that we're not going to solve large N QCD. We're not going to find the definitive model of high temperature superconductivity using these techniques. But it provides a very interesting addition to the general toolkit of theoretical physicists. And I hope, will lead to some truly new insights into strongly coupled dynamics. So let me try to give a little bit more detailed review, and I've tried to organize the talks by topic. This is not always 100% accurate because many talks went over several different topics, but I grouped several together in supersymmetric gauge theory and string theory, and I've tried to put red lines here to remind you of when these talks were given. So 2 of them just recently, and I won't have that much to say because I didn't have that much time to prepare, and they should be fresh in your minds. So on the very first day, remember, we heard Nadi Seiberg quite remarkably talking about some rather mathematical topics, but in a very physical way, and giving a precise way of how to understand exactly how you define a supersymmetric gauge theory by giving a complete specification of its behavior when defined on manifolds of non-trivial topology and in the presence of line and surface defects. And this led to new insights into the possible phase structure of supersymmetric gauge theories, rather analogous to the subtle structure that's led to topological insulators in certain condensed matter systems. We heard a very nice talk about the study of two-dimensional supersymmetric gauge theory via localization and computation of exact partition functions, something that was connected to David Morrison's talk, which I'll mention later, because it gives you a way via the GLSM to compute the Kähler potential of certain Calabi-Yau manifolds. We heard a very nice talk by Komorgodsky, which was not only on 3 manifolds in n equals 2, but I obviously missed out here in my guess, but included an extension of this to n equals 1 theories on 4 manifolds, and from my limited understanding of the subject, seemed to take many previous results and put them into a very nice framework where you could sort of understand and predict much of the structure, or at least some of the structure that's emerged in these computations. And we also heard a very nice talk about the connection between supersymmetric gauge theory and CFT, and some connections between the computation of partition functions and their behavior and the conformal bootstrap. Now, we also heard a number of talks on twistors and amplitudes, perhaps not quite as many as in some of the previous strings meetings, but we heard a very fascinating, to me, reformulation of n equals supergravity in terms of string theory and twistor space, at least at tree level, which is something that I think many people have wondered about, and it's nice to see some explicit thing actually working. I guess it'll be very interesting to see what happens when you try to include loops and actually connect the supergravity to string theory. We heard a nice talk about computation of non-perturbative Wilson line observables in n equals 4 super Yang-Mills, and Nima gave us a very nice overview of his ambitious program to make Yangian symmetry manifest and sort of life on and beyond the positive Grassmannian. Again, I won't say too much because we just heard this very nice talk. We heard two talks, one by Igor and one by Matthias Gabriel on higher spin and holography. Igor talked about induced gauge theory, where you take a gauge theory, for example, QED, coupled to massive fermions. You look at it in the infrared when it can integrate out those fermions. And he argued that such theories are dual to higher spin Vasiliev-like theories in anti-de Sitter space, but with a modification of the boundary conditions. And he developed some additional evidence for this duality. And Matthias also discussed Vasiliev higher spin in ADS and its duals to gauge theory, weakly coupled gauge theory, and had an extension of this that involved a large n=4 superconformal algebra and a duality with that to ADS 3 times S3 times S3 times S1, if I'm keeping track of all the sphere factors correctly. And then we had a number of talks on what you might call applied ADS-CFT, where attempts were made to take the formalism of ADS-CFT and apply it to real-world problems that are hard to understand. So we heard a talk from Sean Hartnoll, and he gave us a way of thinking about transport phenomenon and effective field theory, emphasizing the breaking of symmetry and how you should think about that in terms of irrelevant and relevant operators. And he also emphasized that ADS-CMT seems to be giving us a kind of new mechanism for pushing degrees of freedom from very low frequencies out towards the ultraviolet and for inducing order 1 anomalous dimensions. Gary Horowitz gave a very nice talk about optical conductivity of holographic conductors and superconductors, including lattice effects, some complicated numerical solution of Einstein-Maxwell equations, but with a very striking intermediate scaling behavior which matches the experimental scaling behavior of certain cuprates like BISCO. And this, to me, sort of cries out for some more general understanding other than coming out of the numerics, but actually trying to isolate some dynamical mechanism that's behind this. We heard a talk from Yannick about this derivative expansion of hydrodynamics using fluid gravity duality, arguing that the radius of convergence was 0, and then trying to interpret the singularities in the Borel plane in terms of non-hydrodynamic modes. And Hiroshi Oguri was again using ADS as a way of trying to understand new phenomena that can occur, studying anomalous hydrodynamics and the far from equilibrium response theory at order energy squared and some of the very surprising effects that come out when you do that. Now these applications I think are extremely interesting and very promising, but perhaps the most spectacular application of ADS-CFT or holography came in an inadvertent comment of slide of Sean Hartnoll's, where he introduced the idea of the holographic insulter. Now, this is a multi-purpose term, and you can imagine many, many possible uses for it. He didn't provide a lot of details, and so you have to use your imagination as to how this might actually be used. But in thinking about it, I tried to, as one does in these systems, once you have an idea, you then try to carry out calculations and find some real-world examples. So I tried to find real-world examples of insults and their duals using holography. So here's an insult. George Bernard Shaw to Winston Churchill: I'm enclosing 2 tickets to the first night of my new play. Bring a friend if you have one. And the dual insult was Churchill's response: cannot possibly attend the first night, will attend second if there is one. Just to show you that there's really something to this, I want to give you one more example. So here's an insult from the Earl of Sandwich to John Wilkes: you, Mr. Wilkes, will die either of the pox or on the gallows. The response, the dual insult: that depends, my lord, whether I embrace your mistress or your principles. There are other applications as well. And one of the subjects that has been undergone very rapid development and now leads to a very beautiful story is the application of ADS-CFT to understanding entanglement, entropy, renormalization group flows. And we heard a very nice overview from Rob Myers of the developments that partly grew out of the proposal by Ryu and Takayanagi for the ADS dual computation of entanglement entropy. And he discussed the connections of that to RG flows and the C theorem, and the recently proved A theorem. And Taki and Nagi gave a very fascinating analysis of a holographic model of a local quench and proposed relations between information and energy that involved the notion of an entanglement temperature. I didn't completely understand it, but it sounded fascinating to me. Now, as I said, there's been kind of a motion towards trying to understand M theory, and particularly the branes in M theory, M2 branes and M5 branes, a very difficult topic. And we had a number of talks on this, Shiraz Minwala, and then we had a session with many talks in a row. So Douglas talked about why the 0-2 theory is hard, gave a survey of various approaches, and discussed in most detail an approach starting from 5-dimensional Yang-Mills, which is what you obtain when you dimensionally reduce on a circle. And in that description, instantons act as particles, and monopoles as strings. And there's an issue here that I must say I don't completely understand, which has to do with the continuous instanton scale size and how it's treated. And then we heard two talks that were related, one by Kerman Vaff and the other by Kim. Both of these were approaches to computing the superconformal index, but they, at least to me, seem to involve extremely different techniques. One was a localization calculation of the type that many people have been doing, starting on S5 times S1, and the other one was an approach where you suspend M2 branes between M5 branes. Those look like strings on the boundary, and then you do a computation of the elliptic genus of those strings. But the results agree and seem to be a way of trying to get at some of the structure of this theory. Shiraz Minwala talked about some of the recent developments in the very fast development of Chern-Simons theory with fundamental matter. He studied various dualities, the rank-level duality, Gavon-Kudasov duality, and the finite temperature behavior, and at some point said that Vasiliev bits are like string bits, and I would love to know what that means, because I don't know what a Vasiliev bit is, but perhaps Shiraz will explain to me at some point. David Berman tried to develop an extended geometry approach to M theory with manifest T-duality, following earlier approaches to doubled and generalized geometry. And Jeffers showed that the 2-0 theory on a squashed 3-sphere leads to Chern-Simons theory with a complex gauge group, and talked about some of the interesting connections of that to the AGT correspondence. Now, we also had a firewall debate, and that was great fun, and my impression is impressionistic. Joe says there are firewalls. Daniel says does not compute. Juan says, I don't care if it doesn't compute. I'm not listening to you. And made a very interesting proposal that the entanglement that we all know and love and teach in quantum mechanics, in a certain limit of very large amounts of entanglement, can actually be viewed geometrically in terms of an Einstein-Rosen bridge, and conjectured very conjecturally that there might be some kind of quantum geometric version of this when the entanglement is less substantial. A really interesting idea. But I think all of the speakers agreed that while ADS-CFT gives a general argument for unitary black hole formation and evaporation, we don't really have the right tools yet, and particularly we don't have a detailed understanding of locality in the bulk from ADS-CFT to understand how it happens and what it implies. So my impression is that there's a real problem. I mean, I haven't really thought seriously or worked on this, but the resolution requires some way of doing more computation and less argument. That is some kind of tractable model that captures the essential physics. So I think it's kind of amazing how long this problem has really resisted detailed understanding. Hopefully we'll find some way of dealing with that in the future. We heard about new connections between mathematics and string theory. Some of these are not completely new, but growing out of previous developments, so in particular in the first 2 days. So Shamak Khatru presented evidence for an extension of the M24 moonshine, which was first revealed in studies of the decomposition of the elliptic genus of K3 into n equals 4 characters, and suggested that it would be visible in heterotic string compactifications, and then by n equals 2 string duality should also be visible in the counting of Gromov-Witten invariants for certain Calabi-Yau threefolds. David Morrison, related to the earlier talk that I mentioned, showed how to compute Gromov-Witten invariance or count curves, not using mirror symmetry as often done, but via a new approach to the quantum Kähler potential. And Sergei Gukov talked about H-class, a generalization of previous classes, which, as I understand it, is a program to establish links between two very difficult subjects, four-manifold theory and the 0-2 theory, extending previous connections between the 0-2 theory and three manifolds and two manifolds, and with some really interesting connections, such as an understanding in the Chern-Simons description of Kirby moves that he says are in every textbook, but unfortunately not in any of the textbooks that I've ever read. So we also heard about string theory, cosmology, and inflation. Eva Silverstein talked about how to fix moduli in string compactifications, that this can lead to de Sitter space and inflationary potentials, and she described a search for and some of the features of simple practical models. Andre Linde suggested the following model, a model of chaotic inflation based on ideas of broken or superconformal invariance. And all I would like to say is that I had this picture up and on this slide before he showed the Model Ts in his talk. But so I claim some originality even though you've already seen it. Now we also heard about experiment, or what might be called triumph of the standard models. Both are great success and the bane of our existence. So Landsberg talked about the amazing performance of the LHC, how it's led to the discovery of the Higgs, gradually improving limits on beyond the standard model physics, and also improved measurements and new measurements of some standard model physics. For example, the measurement of direct CP violation in BS decays. So I think at this point we all eagerly await data from 14 TeV. I was also amazed to hear that the LHC is going to be running and doing interesting things until something like 2030 or 2033. And I tried to figure out how old I would be at that point, and I got rather depressed, so I stopped doing the computation. And we also heard what, to me, is even a more amazing story of measurements of the CMB spectrum, which have culminated recently in the Planck data. And I think if I were to name one thing that's been the most dramatic development in physics since, say, 1984, when I started doing string theory, it is the evolution of cosmology into a precision science and the confirmation of a standard model whose ingredients the ingredients existed, but no one imagined such a thing 30 years ago. So in particular, 30 years ago, I think most people had no understanding of the cosmological constant problem, but they were, if you had to make them bet, they would bet that it was zero for some reason that we hadn't figured out yet. We now know that it's not zero, and not only do we know it's not zero, we know, this measurement changes the value by 5%, and they're quoting numbers with 4 significant digits. That's an astounding fact to me. The fact, it's not amazing that the universe is 13.819 billion years old, unless you're a creationist, but it's amazing that anybody would write down a number with 5 digits in talking about the age of the universe. That to me is absolutely astounding. And we also heard some new approaches to old problems. At least that's what I'm sort of using to classify a number of talks that I couldn't fit easily into some of these other topics. So we heard about the revival of the conformal bootstrap and a detailed numerical implementation of these principles. And one of my favorite quotes of the meeting, if it's if it's mathematically well-defined, you can put it on a computer. If it's not, you just have to solve it. I really like that. Andy Strominger, inspired by holography and a reinterpretation of Weinberg's theorem due to Molosena, extended the BMS analysis of asymptotic symmetries to gauge theories, even QED with massless matter, and suggested that there was some connection to affine Kac-Moody algebras at a level inversely proportional to the coupling squared. A fascinating suggestion that I also don't entirely understand. And John Schwartz gave us a kind of modern, I just understand the problem here, a modern point of view on the classic story of SL2Z, symmetry in 2B, and the origin of the 2-0 theory. Ashok Sen described how in any perturbation theory, in any interesting theory, you have a divergence in the perturbation theory, but in certain string theories or gauge theories, like n equals 4 super Yang-Mills, we have the tool of S-duality, and so we know this asymptotic expansion, both at weak coupling and strong coupling, and he used that information to put together a scheme for trying to match on those two behaviors, an interpolation method, and used that to study the value of certain physical quantities at intermediate coupling. For example, I think he looked at the computation of the mass of the stable spinor state in SO32 string theory. And I think the sort of the main message here was that things don't vary as much over the range of coupling if these methods are accurate as you might think. They're sort of order one. And Svetich talked about the mathematical subtleties of U1 factors in F theory. I guess you could have called this a string phenomenology talk, but it was a very mathematical one and kind of fascinating to me that something as subtle as the structure of the Mordell-Weil group of elliptic curves has implications for string phenomenology. We then had a number of talks about what you might call BPS-ology, which of course is not disconnected from talks on the structure of supersymmetric gauge theory. So we heard from Yin and then Manchat and Moore. Piljani gave a very beautiful overview of wall crossing of BPS states from the earliest days to the latest developments, talked about how you can physically check the idea of, or the proposal of Kontsevich and Soibelman, and it seems to me like this has been a really interesting adventure, and as far as I understand it, it's not completely extended to n equals 2 string theory, and understanding how that arises and the connections to black holes and black hole counting sounds like a great adventure. Yin studied 1/16 BPS states in n equals 4 super Yang-Mills and talked about what seems like a rather sharp puzzle in that you don't correctly account for the entropy of large black holes in ADS5 in the matching of the number of these states, and so it will be interesting to see how that gets resolved. He had several proposals. Manchat studied BPS bound states, of the kind of fundamental bound states via quiver dynamics. And Greg Moore gave us news on the spectrum of BPS states, 4 talks in 1, award for cleverest slide, but he's a man with questionable motives. So that is, I think, includes all the talks. My greatest fear is that I have omitted one or somehow misrepresented something that someone did. And if I did that, I apologize. It was inadvertent. But overall, I thought the talks were extremely interesting, very stimulating, and the conversations I had with people were also wonderful. And so thanks to all of you, the speakers in particular, for all your hard work. And that's the end.